Section 7.1, this is discussing fundamental identities. A lot of what we're going to be doing in Section 7.1 and 7.2 is going to involve a lot of algebra, so you're going to have to just sort of refresh your memory, and I'll remind you of this, but refresh your memory on all of the ways of factoring and that sort of, all the different things that you've done. Section 7.1 is covering the fundamental identities. In your notes, you have a formula sheet that I've attached. This is going to be very helpful. You really should know all of these on here because they have been discussed before, but just having it all in one place is going to be very helpful. And there's a couple of new ones that I'm going to be adding to it as well. So let's read through what we have at the beginning of section 7.1. We have seen that the graphs of sine x and tan x have symmetry with respect to the origin. Okay, so here's the graph of sine x. Alright, symmetry with respect to the origin just means that if you have a point up here, it's going to have a twin down here, the same distance from the origin. Tangent is the same. Any point that you have up here on your graph will have a mirror image down here in quadrant 2. Since these graphs have symmetry with respect to the origin, we say that they are odd functions. Also, we know from Math 171 that for odd functions, really the definition of an odd function is f of negative x equals negative f of x. What does that mean? That's saying that if you put a negative value into an odd function in place of the original x, so if you replace the original x with a negative x, it's gonna make the entire function negative. Okay, so this is just to kind of just to help us understand what we're getting ready to talk about. Because of this, you end up with the following identities: sine of negative theta equals negative sine theta, because it's an odd function. Also, same thing with tangent. Tan of negative theta equals negative of tan theta. Okay? Since y equal cosine x has symmetry with respect to the y-axis, it is an even function, and for even functions, f of negative x is equal to f of x. So that's just saying that with an even function, replacing x with a negative x will give you the same function back, so that negative ends up disappearing. And of course, here's a graph of the cosine function, just showing what the symmetry with respect to the y-axis looks like. If you were to fold this down the y-axis, everything should come together and touch for you. So because cosine is even, we get this identity that states that cosine of negative x is equal to negative cosine of x. Oh, I'm sorry, not negative. Let me get my white out. I think that's the one that doesn't work. Yeah. Alright. So because cosine is an even function, we have this identity that states cosine of negative x equals cosine of x. So putting a negative in place of x in your cosine function is just going to give you the original function back. So these three new identities are new to this section. And of course their reciprocals are going to follow the same pattern. So on the next page, we've got all of them listed. Okay, so here's the three that we just talked about. And then if you take the reciprocals, the signs are still going to follow the same pattern. So cosecant of negative theta is the reciprocal of sine. So cosecant of negative theta is equal to negative cosecant of theta. That means cosecant, of course, is an odd function, just like sine is. Secant is an even function, just like cosine. Cotangent is an odd function, just like tangent. These even and odd identities, together with the reciprocal, quotient, and Pythagorean identities, make up the fundamental identities. So again, on that formula sheet, we have the reciprocal identities, the Pythagorean identities, the quotient identities, and then these new ones, the even and odd identities, added onto those. And I've also got the definitions of the functions up here too. But all of these taken together create the fundamental identities. And in this section, we're going to just be using those identities to do problems like we've been doing basically all along. So these three examples that we're getting ready to do together Some of them you may be able to do the way you did before with reference angles and all silver teacups. You can still do it here. It still works. We're just going to look at how we can do it using the identities now. So in example 1, if tan theta equals negative 5/3 and theta is in quadrant 2, find each function value. So if I'm in quadrant 2, let's think about what's going on with all these signs. The angle is over here in quadrant 2. We know all silver teacups tells us that sine is going to be positive in quadrant 2. And of course its reciprocal, cosecant, is also going to be positive. But everything else will be negative in quadrant 2. So we'll keep this in mind as we're doing our calculations. So in part A, we're asked to find secant. So let's look at our identities. Excuse me. Looking at our identities, we need, we're looking for an identity that includes tangent and also has something about secant. So we can see that occurs right here. Tan square theta plus 1 equals secant square theta. So I'm going to use this one. And sorry about my fan making so much noise. Let me go cut that off right quick. Okay, so if we substitute the negative 5/3 in for tangent, and we'll be squaring it, plus 1 equals secant square theta. Alright, squaring negative 5/3 will give us 25/9. And you can do 9/9 for 1, because I'm not going to use my calculator to do it. I don't need it. Adding that is going to give me 34/9. And then to solve for secant, take the square root of both sides. The square root property tells you to do plus or minus the square root of your constant, but we already know we're only going to use one of these for this problem. So we're getting secant theta equals plus or minus the square root of 34 over 9, and that needs to be simplified to square root 34 over the square root of 9 gives me 3. What do we say about the sign for this? Is it going to be positive or negative? Okay, so this is secant, and going back up here, in quadrant 2, secant is not, this is not the secant, this is not the cosine quadrant. So secant is negative in quadrant 2. So our answer is negative square root 34 over 3. Okay, for part B, we're going to find sine of theta. I'm not sure if I'm going to be able to get it all in here, but I'm going to try. So for part B, sine of theta. So do we have a formula or an identity that has sine and tangent that we can use? Well, we could try this quotient, sorry, where did I go? This quotient identity here. Sine theta over cosine theta equals tan theta. So let's see if that'll help us. Sine theta over cosine theta equals tan theta. Alright, now, we're solving for sine. We were given tangent, so we could put negative 5/3 in for tan. We don't have sine. What about cosine? Do I have anything I could put in for cosine? Well, yes, I do, because in part A we found secant. So remember, secant was this negative square root 34 over 3. So that tells us that cosine is the reciprocal of this. So it's going to be negative 3 over the square root of 34. Okay, so we got this big nasty fraction here, but that's okay. To solve this, we could, why don't you just multiply both sides by this fraction? I think that's probably the easiest way to do it. So you'll have sine theta equals negative 3 over the square root of 34 times negative 5/3. So sine theta equals, the 3's cancel and the negatives cancel. I've got 5 over the square root of 34. Rationalize the denominator, and that gives me 5 square root 34 over 34. Okay, now I'm getting a positive here. I need to go back and make sure that's what I should be getting. Going back up here to your angle, we're in quadrant 2. We know sine is supposed to be positive, and that's exactly what we're getting, so we're good on that. So 5 square root 34 over 34 is sine theta for part B. Alright, and then for part C, I actually have space to do part C because part C is easy. In part C, I'm asked to find cotangent of negative theta. Well, because tangent and cotangent are odd functions, that's the same thing as putting the negative in front of the function. So I'm going to find negative, and I'm sorry to have to move it around. Let me zoom out. Okay. So cotangent of negative theta is the same thing as negative cotangent theta. Okay, and cotangent theta is, of course, the reciprocal of tangent, and we were given tangent. What was tangent? Tan theta was negative 5/3. So we just need to do negative reciprocal 3/5. And let's see, there's actually the negative from the cotangent function that we're working with here, and also the negative from the original tan value they gave us. So we have a double negative. Negative 3/5. So my answer is positive 3/5. Okay, so I got that again from cotangent is an odd function just like tangent. So cotangent of negative theta gives me negative cotangent theta. And then I'm just going to substitute the negative 5/3, but just use so I'm going to use the reciprocal negative 3/5. Put it in here. We get a double negative, so our answer is positive 3/5. So that's example 1. Example 2. We are asked to write cosine x in terms of tan x. So let's go back to our identities and see if there's something that's going to help us. We want a formula that has tangent and cosine. Okay. Now we've got this one, but it's also got sine, and that's kind of in our way. We don't have anything to put in for sine, so that's not really going to help me this time. However, this one does. I've got tan square theta plus 1 equals secant square theta, and of course secant is the reciprocal of cosine. So we're going to use the same identity again that we used earlier. So tan square theta plus 1 equals secant square. And of course, secant is we're going to replace that with 1 over cosine. So tan square theta plus 1 equals 1 over cosine square theta. Oh, I'm sorry, we're supposed to be using x, aren't we? Okay, so we need to solve this equation for cosine. Not that big of a deal. You're just doing a lot of algebra for section 7.1 and 7.2. You're doing a lot of algebra for these problems. So we can solve this for cosine. Let's get it out of the denominator first. You could take the reciprocals of both sides, and you would have 1 over tan square x plus 1 equals cosine square x. And then I can take the square root of both sides to get cosine. And again, when you do the square root, you have to do plus or minus the square root. So 1 over tan square x plus 1 equals cosine x. Okay, so technically this is it. We've done it. We've written cosine in terms of tangent, but we do have to rationalize our denominator. So to do that, we'll have plus or minus square root. Let's see. Let's break it apart first. You can write this as 1 over the square root of tan square x plus 1 equals cosine x. And let's see. Now we're going to multiply the top and the bottom by that square root to get it out of the denominator. So plus or minus the square root of, I'm going to write 1 plus tan square x just so it doesn't look like a horizontal shift or a phase shift going on with this. And then if I multiply the denominator, so what did I do there? Let me make sure that's clear. I'm rationalizing my denominator. I'm doing square root tan square x plus 1 over square root tan square x plus 1. So multiplying the top and the bottom of that square root. My denominator is just good. The square roots are going to cancel out and give me the tan square x plus 1, or 1 plus tan square x equals cosine x. Okay, and that's the plus or minus sitting out here. Of course, plus or minus, the sign will be determined based on which quadrant the angle lies in. Okay, so we have solved this for, this has been solved for cosine, so that's it. That's example 2. So what you're doing in this section is learning how to manipulate all these formulas to solve for whatever they're asking you to solve for. Example 3, we're asked to write 1 plus cotangent square theta over 1 minus cosecant square theta in terms of sine and cosine, then simplify so that no quotients appear. So we have to write all this first in terms of sine and cosine. So we're going to say 1 plus, all right, what can I do with cotangent square theta? Well, I know that cotangent is equal to, well, let's look at this. All right, we know that tangent is tangent is sine over cosine. So cotangent would be cosine over sine, so we can put that in there. And of course that's going to be squared, because it was cotangent square. Over 1 minus, and then cosecant squared is 1 minus sine square theta. Okay. So we've got it. So we've got the problem in the form that they're asking us for. We just need to, now they're wanting us to simplify so that no quotients appear. I'm going to slip some paper under this. All right, so we're solving this now to get it to where there are no quotients. It's okay if our final answer does not have sine or cosine. That could happen. It's okay. We're going to simplify this as far as we can so that we don't have, and when it says no quotients, of course, they mean no fractions. Okay, so you may or may not remember how to simplify something like this. So you got this big fraction with fractions in the top and in the denominator, but you'll notice that the denominator in the top of the big fraction is sine square theta, and the bottom fraction also has the same denominator, sine square theta. That means that we can multiply the top and the bottom of this by sine square theta. That's the LCD. So let's multiply this entire numerator by sine square theta, and then we'll multiply the entire denominator also by sine square theta. This is going to eliminate our fractions when we do this. So we'll have to distribute. So distributing it here, you're going to have sine square theta plus, and then these cancel out and leave us with cosine square. In our denominator, we'll distribute, we'll have sine square minus, and then these cancel and leave us with 1. Okay, so it's looking better. How can I make some substitutions even further, hopefully to eliminate that fraction? Go back to your identities again. In the numerator, you've got sine square theta plus cosine square theta. Okay, we know from our Pythagorean identities that this is equal to 1. So that substitution can be made in the top. Right, in the denominator, I have sine square theta minus 1. What can I do with that? Well, of course, you can manipulate these identities as well. So if you take take this same identity and solve this for you've got sine square minus 1. So if you take your sine square plus cosine square equal 1 identity and put it in this form, sine square theta minus 1, what is that going to give us? If we subtract 1 here and here, and then and then subtract cosine square, you find that sine square theta minus 1 is equal to negative cosine square. So, this sine square theta minus 1 that you have in this denominator can be replaced with negative cosine square theta. Now, how does that help us? Well, it looks a little bit neater. And now that you've got, back in the previous step, it was harder to get it into just into an expression that did not have fractions. Now it's easy to do that. This is easy to convert. We know that the reciprocal of this is secant, so we can write this as negative secant square theta. And that's it. Okay. So that's it for the notes for the examples in this section. I am going to pick a few homework problems to go over with you. So we'll take a look at those next. Okay, the first example from the homework that I'm looking at with you, we're asked to find sine of theta if cotangent theta equals negative 1/5 and theta is in quadrant 4. So if we're in quadrant 4, all silver teacups, so this is cosine and secant are positive here. We're finding sine, so our answer is going to be negative. So sine is negative. Okay. Now, how are we going to, again, these problems, if you want to do them the way you did them back in chapter 5, I think it was chapter 6, it's still the same, it still works the same, but it's just good to know another way to do it because sometimes it's going to be easier one way versus the other. So we're going to use the identities to go through this, and let's see, we've got sine, we're finding sine, we're given cotangent. So what identity might be useful? I would go here. 1 plus cotangent square theta equals cosecant square theta. We know cosecant is the reciprocal of sine. So we'll use that one. 1 plus cotangent square equals cosecant square. So, put in the information we're given. So we got 1 plus negative, that's the negative 1/5. Hopefully you can see it. Square that equals cosecant square. So 1 plus 1 over 25 equals cosecant square. That's going to be 25 over 25 plus 1 over 25. That's 26 over 25. Okay? So that means that sine square is equal to the reciprocal 25 over 26. Then we need to do the square root of both sides. So we'll do, we know we're going to use the negative answer. So negative square root of 25 over 26 equals sine. So that gives me negative 5 over square root 26. And then I just need to rationalize the denominator. So it's going to give me negative 5 square root 26 over 26. For my answer. And that's it. You get the same answer if you did reference angles and all silver teacups. We did all silver teacups anyway, but you get the same answer if you did the reference angles. So that's negative 5 square root 26 all over 26. Okay, and then the last example that I'm doing from section 7.1, this is another homework example. You're going to have to find the remaining 5 trig functions of theta if cotangent theta equals 4/3 and sine theta is positive. So first decide what's going on with the signs of these trig functions. Look at the unit circle or draw your angle. Cotangent is a positive value, so that means tangent is positive. So if tangent is positive, then you could be in quadrant 1, or all silver teacups, T, so you could be in quadrant 3. So it's either quadrant 1 or quadrant 3 based on cotangent positive. then it tells us that sine has to be positive. If sine is positive, then it's got to be in quadrant 1, because sine is negative in quadrant 3. So we're in quadrant 1, and if you're in quadrant 1, everything's going to be positive, so all of these answers will be positive. So all positive here. And then we're ready to go through and find everything. So we're given cotangent, and we're asked to find all the other ones. So really, you can just pick one of these to start with, as long as you've got a tangent or a cotangent to work with, and you can go to, you can go here. 1 plus cotangent square equals cosecant square. Okay, so we can substitute 4/3 in. Square. That's going to be 1 plus 16/9. And that's going to give you 25/9. You'll take the square root of both sides. So square root 25/9 equals cosecant. I didn't have to do plus or minus because I know all of these answers are going to be positive here because I'm in quadrant 1. So that gives me 5/3 equals cosecant theta. If that's the case, 3/5 is sine. So I've got cosecant and I've got sine. And I've got cotangent, and I can easily get tangent. Tangent's going to be 3/4. So that just leaves cosine and secant. And to get that, you can maybe go to this one. Sine square plus cosine square equals 1. You can use that one if you want to, or you can use this one. It doesn't really matter. I'm going to do sine square plus cosine square equals 1. Oh, my children are getting ready to come running in right at the end of the video. So sine square is 3/5. Excuse me, I got to go unlock the door. Okay, so we're using sine square theta plus cosine square theta equal 1. We already found sine to be 3/5, so we're substituting that in. We're going to solve for cosine. So 3/5 squared gives me 9/25. Alright, then I'm going to subtract 9/9/25, so I've got cosine square theta equals 1. That's 25/25 minus 9/25 gives me 16/25. And I'll take the square root of both sides. I get cosine theta equals square root of 16/25. So cosine equals 4/5. And again, you don't have to do plus or minus here because you know your answer is positive. So cosine theta is 4/5. And secant theta, of course, is going to be 5/4. And we have found all of the trig functions for this problem. So you can do it the way you did before with the reference angles and the Pythagorean theorem, or you can use these identities to do it this way, whichever way you prefer. So it's just another way to get to the same result. Alright, so that is it for section 7.1, and we will be working on these together in class. Thank you.